So let us see, this is the problem on CST element, but in this case we need to find the stiffness matrix of CST element. Even though they have mentioned this is a plane stress element. Why they have especially written here plane stress element, we will discuss it later on as we will be solving this problem. Then this is the CST element, node number 1, 2, 3. The coordinates are given x1, y1, x2, y2, and x3, y3. E value, Young's modulus value is given 210 into 10 to the power 3 Newton per mm square. Nu value is given 0.25. Nu value is nothing, your Poisson's ratio. T is given, that is thickness is given 10 mm. So we need to find the K matrix, and we know for a stiffness matrix of CST element, the K matrix can be written as, the stiffness matrix can be written as B transpose into D into B matrix into area into thickness. So thickness is given, area we need to find. Then B matrix, what is B matrix? We will see. This is our D matrix. D matrix, again for this D matrix only they have mentioned this, that this is a plane stress element, because D matrix we will use for plane stress condition. Then B transpose, once we will find this B matrix, B transpose automatically we will find, right? So let us start now. And we know that at node number 1 the coordinates are x1, y1, node number 2 x2, y2, and node number 3 x3, y3. So first we are going to find this area. So first we are going to find the area. So how we will find the area? Area can be found as 1 by 2 1 x1. Formula is 1 x1 y1, 1 x2 y2, and 1 x3 y3. So let us replace these x1, y1 by the values given here. So we will get half determinant of 1 x1 is 30, given in the question, that is 30, right? So 130, and y1 is 20, 1 80 20, and then 1 x3 y3 is nothing, 50 100. So we need to find the area. Here just we need to solve the determinant. So let us solve. Then how we can solve this? Half will be outside. Then from here we can say, if we take this outside, then 1 into this will go off, 80 into 100 minus 50 into 20. So 8000 minus 1000, then again minus 30 to 100 minus 20 plus 20 into 50 minus 80. Just I have expanded this determinant in along this row number 1. Along this row number 1 I have expanded, right? If I will take 1, then this row and this column is going to, then 80 into 100, 50 into 20. Now as we will take 30 outside, so this will go off, this will go off. So remaining will be 1 into 100, and here 1 into 20. So 100 minus 20. As we will take 20 outside, so this will go off, this will go up. So this will be 50 into 1 minus 80 into 1. So 50 minus 80. As we will solve this, we will get the area value. So from here directly I am going to write area. Area as after solving this divided by 2, I am going to write it directly. The value is going to be 2000 mm square. 2000 mm square. Now area we have calculated. Next thing I am going to calculate is this B matrix. Next one, our aim is to calculate this B matrix. So let us solve this B matrix now. This B matrix, we know this B matrix is nothing. What we will call for this B matrix? B matrix is our strain displacement matrix. This is called as strain displacement matrix. So a strain displacement matrix values we know that can be written as 1 upon 2 into area 2a here beta 1 0, beta 2 0, beta 3 0, then starting again 0, gamma 1 0, gamma 2 0, gamma 3, and then here we will have gamma 1 beta 1, gamma 2 beta 2, gamma 3 beta 3. So we need to find this beta 1 beta 2 beta 3 value, gamma 1 gamma 2 gamma 3 value. So if we will find these 6 values, we are going to get this B matrix, because we have A also, right? So let us find this beta 1 beta 2 beta 3. So let us find. Here I am going to find beta 1. Beta 1 will be nothing. Beta 1 is nothing. Y2 minus Y3. This is the formula. In the previous class I have discussed these things. Beta 1 value, beta 2 value. In the last problem also, if you will see that, if when we were analyzing the problem using shape functions, in that I have given alpha 1 alpha 2 alpha 3 beta 1 beta 2 beta 3 gamma 1 gamma 2 gamma 3. From there itself you can see this beta 1 values. So beta 1 is nothing, y2 minus y3. If we will put y2 and y3, y2 here is 20 minus 100, that is going to be minus 80. Next, beta 2. Beta 2 is going to be y3 minus y1. So putting y3 100 minus 20, everything is given in the question, that is 80. Then beta 3 value will be y1 minus y2, that will be 20 minus 20, that is equal to 0. Then coming to gamma 1 value is going to be x3 minus x2, 50 minus 80, minus 30. Then gamma 2 value is going to be x1 minus x3, that will be our 30 minus 50 minus 20, and gamma 3 value is to, we will take it as x2 minus x1, 80 minus 30, which is equal to 50. Whatever the values x1 x2 x3 already given in the question, these all are x1 x2 x1 y1 x2 y2 x3 y3. From here itself I have taken the values. So we got these values, just we need to replace here. So now beta matrix, once we will find 2 into area also, so this beta matrix can be written as, once you will put all these values here, area value, just put area value, you put all these values, we are going to get this beta matrix as B matrix. This B matrix we are going to get as 1 by 400 minus 8 0 8 0 0 0, then 0 minus 3 0 minus 2 0 5, then we will have minus 3 minus 8 minus 2 8 5 0. This is our B matrix, a strain displacement matrix we have calculated. This will be our B matrix. So we have calculated two things. We have calculated thickness already given, we have calculated A, we have calculated B. Just as soon as we have calculated B, we can calculate B transpose also. So let us calculate now B transpose. What will be B transpose? So let me write here, B transpose matrix can be written as 1 by 400 as it is outside. So transpose, how you are going to find? Just make the row 1 into column 1. Just convert the rows into column. This is row, make it row. This is row number 1, make it column number 1. So just you have to write the horizontal will be converted into vertical, right? So here the elements are minus 8 0 8 0 0 0. So how will you write here? We will write here minus 8 0 8 0 0 0. Next row is R2. So 0 minus 3 0 minus 2 0 5. So write it here. Second column, make it second column. So second column, as soon as you will make, it will be 0 minus 3 0 minus 2 0 5. Same we will repeat for R3 also, that R3 will change into C3. So Let us write here -3, -8, -2, 8, 5, 0. So we have calculated B transpose also. Now, what is unknown for finding a stiffness matrix? Unknown is now this. This is unknown, D matrix. So D matrix, for D matrix, we need to see whether the given problem is plane stress problem or plane strain problem. So this is your plane stress problem. As soon as we come to D matrix, we need to see the condition, whether it is plane stress condition or plane strain condition. So this is plane stress condition. So as soon as we know this is plane strain condition, so the D matrix is going to be, the D matrix we can write it as matrix D. This is for plane strain, plane stress condition. If the element is following plane stress condition, then we can write D matrix can be written as E by 1 minus nu square, new value is given, into 1 nu 0 nu 1, this is 1 0 0 0 1 minus nu by 2. This is D matrix. So what we need to do, we need to put the values of E nu here just as soon as, because these things will be given. See here, E value is given, nu value is given. As soon as you will put these values, you are going to get this D matrix. So I am directly writing this D matrix. So by putting all the values, we are going to get this D matrix as, just you need to put here E, 1 minus new value is given, I think 0.25, yeah, 0.25 whole square, and then here 1, 0.250. So as soon as you will put it here, we are going to get this as 56 into 10 to the power 3 to 4 1 0 1 4 0 0 0 1.5. Okay, so this is D matrix. Now what is unknown? Everything is known now. Everything is known. This is also known now. This is unknown. This is known. This is known. This is known. So we can find this K matrix. Now let us find K matrix, a stiffness matrix. Let us find now K matrix. So K matrix is nothing, B transpose matrix into D matrix into B matrix into area into thickness. So is equal to B transpose. B transpose already we have found 1 by 400 minus 8 0 minus 3 0 minus 3 minus 8, then we will have 8 0 minus 2, then we will have 0 minus 2 8, then we will have 0 0 5, and last is 0 5 0, right? This is B transpose. Then we have D matrix. What is our D matrix? Into D matrix. D matrix is 56 into 10 to the power 3 410 10 0, then 140, and then we have 0 0 1.5. Then we have B matrix. So B matrix is again 1 by 400 minus 8 0 8 0 0 0, then 0 minus 3 0 minus 2 0, 5, next -3, -8, -2, 8, 5, 0. This is our B matrix into area. So into area we have already calculated 2000, right? Mm square, 2000 mm square into thickness. Thickness is given in the question. How much? 10 mm. So we will take thickness as 10 mm into 10. So once you will calculate these things, you will get a stiffness matrix. Now how to calculate? That is the question, big question, how to calculate these things. So if you will see what is the size of this matrix, first thing what we will do, whatever the outside things are, outside this matrix, these things and these things, everything we will take at once, means everything we will take here itself. We will multiply the things, whatever the things will be there, we will multiply and divide, and we will write outside. Now the remaining task is to multiply these three matrices. Once you will complete this multiplication of these three matrices, you are going to get our stiffness matrix. So how to multiply? If you will see this matrix is of size 6 by 3, right? This matrix, if you will see, this is of size 3 by 3. And this matrix, if you will see, the size of this matrix is 3 by 6. I hope you know how we will write, how we are going to write this size of this matrix. Size of matrix is determined by M cross, written as M cross N, where M is number of rows, N is number of columns. So here number of rows is 6. One row, row number 1, row number 2, row number 3, row number 4, row number 5, row number 6. 6 rows, how many columns? Column 1, column 2, column 3. So 3. Similarly here, row 1, row 2, row 3, column 1, column 2, column 3. So 3 by 3. Here, rows 1, 2, 3, column 1, 2, 3, 4, 5, 6. So 3 by 6. One more thing you should understand, whenever you are going to multiply two matrices, the suppose first matrix having M cross N, then second matrix, if you are going to multiply two matrices, first matrix is having M cross N, then if you are going to multiply the other matrix, it should have N cross, it may be anything. Now here it may be M, P, Q, R, S, anything, but the number of columns in the first matrix must be equal to number of rows in the second matrix. If these two are not equal, we cannot multiply these two matrices. So here see, these two are equal, so we can multiply. Here also these two are equal, so we can multiply. So based on your choice, you can multiply, because multiplication of matrix cannot be done at once. If you want to multiply three matrices, first you need to multiply any two matrices, then the result of that matrix will be multiplied with the third matrix. So here what you will do, just you need to multiply these two. Let us take this as, you are going to, in first term you are going to multiply this and this matrix. So whatever the result will come, what will be the size of that matrix? That size, this 3 and 3 will cancel out, the size will again 6 by 3. Then this matrix will be multiplied with the third one. Then whatever the result you will get, the new matrix, that new matrix will be of size 6 by 3. How I know that is going to be 6 by 3? Because these two are going to cancel out. What is remaining? 6 from here, 3 from here. So 6 by 3. Then you multiply this with this matrix, which is of size 3 by 6. So again, this will cancel out. So what will be our final stiffness matrix? The final stiffness matrix, you can see 6 from here, 6 from here. The final stiffness matrix is going to be of size 6 by 6. Matrix is going to be of size 6 by 6. So obviously when we are solving for CST element, it is should be of size 6 by 6. Why it should be of size 6 by 6? Because at node number 1, how many unknowns are there? At node number 1, we have two unknowns, U1, V1. Node number 2 u2 v2, node number 3 u3 v3. So how many unknowns? 1 2 3 4 5 6, displacements are there. So once 6 displacements are there, the stiffness matrix is going to be 6 by 6. So by here we can see that our equations are correct and we are going to get this matrix as 6 by 6. So what is your work now? Just you need to multiply these matrices and get the final result. That's it. I am going to write the final result directly, so that after multiplication you can match whether you are getting the correct answer or not. It is a simple mathematics, nothing else, right? No concept, nothing, just a basic matrix multiplication. Yeah, obviously here you have to multiply it twice, 2 times, but still okay, fine. If you all want that 15 or 20 marks for a problem, then this much you should do. So I am going to write the final value of the matrix, stiffness matrix, that you will get after multiplying this. That K matrix, the K matrix is going to be of size 6 by 6, and the value as follows. It is going to be 269.5, 60 minus 247 minus 20 minus 22.5 minus 40. $60, 132, 0 minus 72, minus 60, minus 60. Next, minus 247, 0, 262, minus 40, minus 15, 40, then minus 20, minus 72, minus 40, 112, 60, minus 40, minus 22.5, minus 60, minus 15, 60, 37.5, 0, minus 40, and then minus 60, 40, and 100. So you can see the size also. This is size 6 by 6, right? The size is going to be 6 by 6. This is our unknown. We have calculated the stiffness matrix now. Okay. So this is all about the problem. So we have discussed this problem and we have calculated the stiffness matrix on these matrices. Just multiply first and second matrix and then multiply the result of the first and second with the third one. You will get the final matrix in this form. So after calculating, I would suggest you to calculate the stiffness matrix and just compare with the given stiffness matrix whether you are going to get the correct one or not. So this is all about the problems related to CST. Especially we have discussed on which plane stress element. Same process we have to do. Each and every step is going to be same. Only if they are mentioning that given element is plane strain element, then only our which matrix is going to change? Our D matrix. This matrix will change. Okay, we will discuss that problem in next class. Okay.